Good evening to our lecturer, Dr. Rubia, and my name is Armin Zakri bin Zulkifli, and my matrix ID is 74185. Today, I will present on my assignment article research on the quality control in the industrial. For this next slide here, I will introduce on the introduction on my research article. Here is the automobile industry is highly competitive with manufacturers continuously striving to enhance product quality and efficiency. A critical aspect of this endeavor is minimizing defects in the assembly line, which directly impacts productivity and customer satisfaction. And then in the vehicle inspection department (VID) of an automobile company, high defects rates were identified as a significant issue that hinder the overall manufacturing process. For for the next slide here is my research article shown here are the topic is a defect reduction with the use of a 7 quality control tools for productivity improvement at an automobile company. Here, for the next slide here, is on the objective where of this article, where to study aim se- to reduce the defects by applying 7 traditional quality control, which is the QC tools. And the 7 quality control tools that have been applying in this research article, which the flowchart, check sheets, histogram, Pareto diagram, a Pareto chart, cause and effects diagram, and skip diagram, and a P chart. For the next slide here is the two crucial sections of the assembly lines. The two scopes of the study was focused on two crucial sections of the assembly lines, where the chassis line, which includes the wheel section and frame engine section with fuel and a battery wiring. The trim line, which encompasses the shed, seats, and dashboards. The methodology involved through site visits by systematic data collection using a flowcharts and check sheets over a 4 months period from November 2015 to February 2016. Here I will explain for the 7 quality control tools that have been applied in this research, where for the first quality control tools is the flowchart. The flowchart was used to provide a visual presentation of the entire assembly process for both the chassis and the trim lines. By mapping out each step in the process, the flowchart helped in identifying stages where a defects were likely to occur. These tools enable the team to focus their effort on critical points in the assembly line where improvement were most needed. For the next slide here, I will continue on presenting the next quality control tools which have been used, and which is the check sheets. Here, the check sheets were designed to systematically collect data on defects. The data collection spanned a 4 month period from November 2015 to February 2016. These sheets record the number and the type of defects encountered in both the chassis and the trim lines. This methodical approach ensures accurate and comprehensive data collection, which was essential for identifying defects, patterns, and trends. For the next slide here, for our I will present on the next for the next quality control tools, the number three, which apply which using the histogram. The histogram we used to graphically represent the distribution of the defects, which are formed in a bar chart for the histogram. By displaying the frequency of various type of defects, histogram help in visualizing the most common issues affecting the assembly line. Where, as you can see from the right side figure, there are two. One is from the chassis line defects, one is to the trim line defects. Then the tools. These tools made it is easier to identify which defects occur the most frequently and require attention. Immediate attention. For the next slide here, I will present on the fourth quality control tools, which is the Pareto chart. The Pareto chart was essential in prioritizing the most significant defects in the vehicle inspection department (VID) by focusing on those that had the highest impact. For as you can see from the graph, uh, graph Pareto chart, at the right side here, there are different involved, which as you can see which one is the upper one is the chassis line defects. For the up for the downward, which is the Pareto chart for the trim line defects. For the chassis line defect, it's identify frequent issue like misaligned wheels and improper fuel line connections, which leading to a 90% defects reduction from 182 to 13 between December 2015 and February 2016. In the Dreamline, it highlighted the common problems such as dashboard misalignment and seat fitting issues, resulting in an 82% reduction from 157 to 28 in the same period. This target approach, based on the Pareto principle, allows the team to allocate resources effectively and achieve substantial improvement in productivity and quality. For the next slide is I will continue on the next quality control tool that have been applied, which is the cause and effect diagram. Diagram. The cause and effect diagram was used to analyze and identify the root cause of defects. By systematically exploring all the potential causes, these tools help the team understand the underlying issues contributing to defects. The fishbone diagram provides a structured approach to a problem solving, ensuring that the root cause were addressed rather than just a symptom. As you can see from the right side here, one from the above is the cause and effect diagram for chassis line defects. The downwards is the trim line defects by using the fishbone diagram. For the next slide here, I will on presenting on the next tool quality control that we apply is the scatter diagram. The scatter diagram will employ to investigate the relationship between two variables. This tool was used to examine correlations such as the relationship between the defect frequency and time on or between specific assembly things and defects occurrence. A scatter diagram provide insights into a factor that contribute to defects, helping the team understand the condition under which defects were more likely to occur. As you can see from the right side, shown the figure For the chassis line defects and the trim line defects, there are difference. As you can see, the data point, some of it has been passed through, some of it have more stack point is passed through. For the last quality control tool that have been applied in this automobile industry is the P chart. The P chart, or we can call it a proportion control chart, was used in the vehicle inspection department, the VID, to monitor the proportion of defective items over time in both the chassis and trim lines. By plotting a defects proportion against time, the team could visualize a trends and ensure process stability. The picture shows significant reduction in defects proportion from December 2015 to February 2016 in the chassis line, and from November 2015 in the trim line. This tool was crucial for maintaining control and ensuring consistent quality, demonstrating the effectiveness of the defect reduction efforts and leading to a substantial improvement in productivity and product quality. As you can see from the right side here, shown the difference between the chassis line and trim line. For our last slide part, for my last slide part here, I will for the conclusion, in this research article, the strategic application of the seven traditional quality control tools, the flowchart, which is the flowchart, the check sheet, histogram, Pareto chart, cause and effect diagram, scatter diagram, and a control chart, which is the P chart, significantly reduced defects in the vehicle inspection department of the automobile company. By systematically identifying and addressing issue in this chassis and the trim lines, defect decreased by 90% and 82% respectively. These tools facilitated accurate data collection, root cause analysis, and process monitoring, leading to improved productivity and product quality. This successful implementation highlights the importance of structured QC tools, which is the quality control tools, in manufacturing, setting a precedent for similar initiatives in the industry. That's all for my presentation on the assignment article research on the automobile company. Thank you for listening